So I think at an audience of KR, probably you guys are mostly on board for what I want to say. And so maybe you can think of this as motivation for doing what you do rather than what I think the field at large is stuck doing. So here's what I wish that we could do with AI, or what some people call AGI. And this is like in context of what's happening now. I sit in Vancouver. This is a picture of Vancouver, but it's not a picture of Vancouver today. You can't see anything right now because of the fires in Washington and Oregon and California, which I attribute to be at least in part from climate change. So we have two crises right now at the same time. We have fires all over the West Coast. Well, there are many crises, but two examples are COVID around the world and the fires on the West Coast. I wish that AI could help with these things. I wish, for example, focusing on COVID, that we could have AI systems that could read and synthesize the fast-growing medical literature. So yes, we have AI that can do keyword search on the medical literature, and that's helpful. If I want to find everything that mentions a particular molecule, I can do that. And so, we've made some progress, but a lot of that is more like information retrieval than true artificial intelligence that could read studies and say, hey, this one's missing a control group, and could really help people in that way. We're missing AI that could reason causally. We would like to have AI that could help us with difficult decisions in the real world, in novel environments, in situations with partial and incomplete information. And COVID is a great example of that, where we don't have a lot of prior literature here, but we want to do the best that we can. I'd also like to see, and this is really what my company is about, robots that could keep humans out of dangerous situations, care for the elderly in hospitals, deliver packages to the door, and so forth. And the field of AI has been here since the 50s, and we really can't do any of this. The AI that we actually have does stuff like play games, transcribe syllables, and vacuum floors. I mean, it's nice to play games, and Roombas are useful, but this is really not where we should be right now. Instead, what we have, and this goes back to the 50s, honestly, is promise. So the latest version of promise is, for example, Jeff Hinton telling us it's just completely obvious that within 5 years, deep learning is going to be better than radiologists. That was in 2016. Or Elon Musk telling us pretty much every year, he says, we'll have those autonomous vehicles next year. And of course, it never actually happens. What really happens, for example, is here's what's going on in radiology. Hinton said, hey, deep learning for radiology is completely obvious. And 400 startups went out there and tried to turn radiology into a thing. But the number of actual radiologists whose workflow has been entirely replaced by a machine is zero. So there's all this promise that we can solve radiology with machines, but it's not realized. I don't think I have time to show you the video that I have in the top right, but Musk is saying in 2020 we'll have driverless cars that take you from your door to your work. And then this video is someone trying to use this feature called Smart Summon to get a car to drive across the street, and it nearly has an accident. And of course, lots of Teslas have crashed into stopped vehicles and so forth. So promises are cheap, but the realization has often been slow. What we have right now fundamentally is deep learning. Deep learning is the most widely used technique in AI. I'm sure you're all familiar with it, even though I would expect in this audience people are doing some other things as well. And to the public's eye, they hear about deep learning and they say, wow, I trained it on all these pictures and it learns what an elephant is. I show it another elephant and it's great. But the reality is that deep just refers to the number of layers in a neural network, not to the depth of understanding in the system. And it's easy to see that, for example, if you go outside the space of elephants on which it's been trained. If you show a silhouette of an elephant, deep learning system might well say it's a person, because what it really cares about are things like texture, the texture of the trees in the background, the texture of the ears and the trunk and so forth. And if you have a silhouette, all that disappears, and the system has no way of reasoning about, let's say that an elephant has a trunk and so forth. So human can readily make this recognition, but a deep learning system can't. If I had hours, I could give you a million examples like this, but I won't bore you with too many, but I'll give you a few. And I'm starting here with perception because that's what deep learning does best. But even there are problems. So you show, and this goes to the point about how shallow the representations are. If you show a deep learning system a school bus on the side of a road, it may very well say with great confidence that that's a snowplow. Again, it's really being driven by texture of the mountains, or the twisty road and the snow in the trees rather than what this object actually is. Or you show it a baseball with foam on top and it may say that it's an espresso. Or another interesting example is you put a psychedelic sticker next to a banana and it confidently tells you that that's a toaster. Any human would actually want a more subtle answer like that's a picture of a toaster near a banana, but the deep learning systems really can just do forced choice between categories. They have no subtlety in what they can report. There are captioning systems that are not a lot better. There was this great example last year from the venture capitalist Benedict Evans, who said, this is why we train autonomous cars in San Francisco. And the point was, if you have weird kind of stuff, which you might find in San Francisco, it's good for your training of your driverless cars. But if you run this through image, a common ImageNet classifier, you can get things like flamingo, griffin, photocopier, shopping cart, and coral fungus. So even on the perception side, there's a long way to go. What deep learning does best is basically take in big data and have complex statistical models looking at correlations of what's going on. And that works fine if you're trying to discriminate tiger woods from a golf ball. This is the only example here, by the way, that's hypothetical. But it doesn't work for reasoning and language understanding. And people are just throwing bigger and bigger models at the problem, I think not understanding what the problem actually is. So about 6 months ago, The Economist got totally sucked in by a system called GPT-2. It'd be nice if I could see my own screen here. Okay, good. So The Economist said, here's an interview with GPT-2. And what they didn't tell, and it looked very coherent. So which technologies are worth watching in 2020? And GPT-2 said, well, GPT-2 is one of these massive language models that uses an enormous amount of input data, training data. It said, well, I would say it's hard to narrow down the list. The world is full of disruptive technologies, blah, blah, blah. It's incredibly coherent, but the reality is it's cut and paste from human beings, number one. And number two, it was cherry picked. So The Economist actually asked the system multiple times and it always picked the best or funniest answer. So it didn't. A human at The Economist picked the best answer. And so it made the system seem more coherent than it is. And this infuriated me. And I wrote about it in Stanford's student journal called The Gradient, and gave examples like a water bottle breaks and all the water comes out, leaving roughly, and the system said 6 to 8 bottles of beer. Well, that was GPT-2. And then along came GPT-3 with 100 times the data. And I don't have a picture of it here, but The Guardian did the same thing that The Economist did, which is the media loves a narrative about the triumph of AI and so forth. And so they cherry picked answers. They ran a story that they said was made by GPT-3. And there was cherry picking behind the scenes there too. So they picked, in every paragraph or whatever, they picked the best option among 8. And the reality is, whoops. Oh, and I had an example from the old one about hydrochloric acid and GPT-2 really not understanding the fundamental biology. So GPT-3 came out and there's all this hype about it, but it's the same thing. And you can read this paper offline that I wrote with Ernie Davis, who many of you from the KR community should know. And we looked at the nature of the reasoning in GPT-3. We found all kinds of crazy results. So the way GPT-3 works is you feed in some text and you get a response. The response is in bold. So here's an example. You poured yourself a glass of cranberry juice, but then you absent-mindedly poured about a teaspoon of grape juice into it. It looks okay. You try sniffing it, but you have a bad cold. You can't smell anything. You're very thirsty. And now the system has to finish it. It says you drink it, you are now dead. Now, this is a great example of where you want good KR. You want to be able to understand that what this is talking about is essentially what happens if you put cranberry juice into grape juice. Now, there's actually data on the web that you could find. In fact, there's a whole commercial drink called cran grape, and nobody that I know of has ever died from drinking Ocean Spray's cran grape drink. But GPT-3 confuses basically the words with the underlying concepts. It doesn't have the concepts. It just has the words. And so you try sniffing it, have a bad cold, can't smell anything, you're very thirsty, must correlate with some story on Reddit in which somebody died because they couldn't recognize what they were smelling. But that's just about how words correlate with each other, not concepts. That's why we need KR. And to me, it all still seems like ELIZA, right? ELIZA's from the mid-60s, and you have a system that can persuasively fool a bunch of people for a brief period of time, but has no idea what it's talking about. So now we can do ELIZA, but with 450 gigabytes of data. I don't see that as genuine progress. So the way I put it is that deep learning is a better ladder, but a better ladder doesn't necessarily get you to the moon. So part of what we need, and again, I think I'm preaching to the converted in the KR audience, but is common sense. And here's a review that Ernie Davis and I wrote 5 years ago or so in the Communications of the ACM. And we didn't make the cover, but the cover captures it pretty nicely, which is here you got a robot that is sitting on a tree limb and it's about to cut down the wrong side. The dominant paradigm right now is if you want a robot to do something, you do it with deep reinforcement learning. You do hundreds of thousands of trials and eventually the robot converges on the truth. Well, you can't do that in robotics, and you certainly can't do it in this case. You don't want 100,000 robots falling down, killing people below, and breaking $100,000 robots and so forth. You just can't do it that way. You have to have knowledge. Here's another example that I think is a fun puzzle for the KR community to think about, which is I can show you this. Most people won't know what it is. It's called a yarn feeder. And as soon as I tell you that name, yarn feeder, you can work out how it's working. So, there's a ball of yarn held in the main thing and then a single strand coming out. And it's obviously to help you while you're knitting. Once I explain one of these, you can recognize another, even if every pixel is different and the whole thing is butt ugly. You still immediately make inferences about what's going on there. Another favorite example of mine, I should tell you that my new company is co-founded with Rodney Brooks, who is a co-founder of iRobot that built Roomba, and he has enormous patience for me showing this slide. But what happens if you take Roomba and you combine it with dog waste is you wind up with something that people call the poopocalypse. I did some fact checking on that because in my spare time I sometimes do some journalism, and what I found out was that this was not fiction. It really happens. It happens so often that iRobot has a company policy about what to do with it. If your robot should suffer this misfortune because it doesn't have enough common sense to recognize the dog waste, they will replace your Roomba because it's too hard to clean after this accident. So to get to common sense, we're going to need a reboot. That's my view. At the bottom, I have a picture of the book that I wrote with Ernie Davis called Rebooting AI. I hope many of you will get to read it. Even cheaper, which is to say for free, is an article that I wrote in Archive earlier this year called The Next Decade in AI, 4 Steps Towards Robust Artificial Intelligence. And I'm just going to, in the rest of the time, mostly talk a little bit about what I said in that paper, a lot of which is also in the book in more popular form. So the first is, I think the fundamental thing we have to do here is we have to build hybrid approaches to AI. People have been thinking about this a long time, but I think haven't thought hard enough about it. I think there are people like Jeff Hinton going around saying it's foolish to even have hybrid approaches. I can't disagree more. Happy to talk even more about it in discussion. But the basic notion is we can't get to AI that we can trust by relying on deep learning alone. It's just not reliable enough. If it's going to see an overturned school bus as a snowplow, we can't count on it. So deep learning is obviously good for some kinds of learning, but it's really terrible at abstraction. Similarly, classical AI by itself, I don't think it's going to get us to robust artificial intelligence either. It's very good for abstraction, and it's not been as good historically for learning. What we really are going to need are hybrid models that bring together the best of the two traditions. So I don't think we should be tossing deep learning out, although a lot of people try to straw man me when they respond. They're like, Marcus says that deep learning sucks. That's not what I'm saying. What I'm saying is it's a tool to be used for certain things. So in a paper that raised a lot of hackles, but I think has also had an impact, called Deep Learning and Critical Appraisal that I wrote in the beginning of 2018, I said this: despite all the problems I have sketched, I don't think we need to abandon deep learning. Rather, we need to reconceptualize it, not as a universal solvent, but simply as one tool among many. It's a tool that's best at perception. As I've shown you, it has problems with perception. It's not that good for language, reasoning, analogy, planning, and common sense. We need to have other tools. KR can help with a lot of those. Another way of thinking about this that I like to give to lay people is we actually all know examples of hybrid models. For example, Danny Kahneman's book, Thinking Fast and Slow, is enormously popular, and it's about a hybrid model of the mind. It's saying that the human mind has what he calls system 1 and system 2. I like to call them the deliberative system is system 2, and the reflexive system that is system 1. These work together in the human mind. Of course, many of you will know Marvin Minsky's book, which is really about an even more complicated hybrid model. And Steve Pinker's book, Words and Rules, which is in part about my own PhD thesis work, is about how even in a very fine corner of cognition, namely inflecting a verb for the past tense, you actually see both elements of associative stuff that looks like neural networks and symbolic rules. And so even at the smallest level that you can imagine, there's evidence for hybrid nature throughout human cognition. Part of the reason that we need it, I think, is that there's an Achilles heel for neural networks, which is fundamentally, and I wrote about this in the book, The Algebraic Mind in 2001, is fundamentally that these systems work well within a space of training examples, but very poorly generalizing outside of them. So the simple example I gave back then is what you might call simply the identity relationships. You have inputs. Let's say they're even numbers. You get some examples of the even numbers. Now you need to generalize to an odd number. Well, it turns out your standard multi-layer perceptron, which is kind of the core of current deep learning systems, can't do this. It will generalize fine from some even numbers to other even numbers. And that's what I have depicted by the white examples getting generalized from the green examples in the center oval here. But it won't generalize to things like odd numbers because they're outside the space of training examples. And as far as the network is concerned, all of those require generalizing between output nodes, and every output node is treated independently. So the systems just don't get it. Simple manipulation, on the other hand, allows us a natural framework for free generalization. And what's critical, and again, a KR crowd, I really don't need to say this, but in the larger community, it's kind of lost these days. What's essential is you have variables, instances, bindings, and operations over those variables. You see them in Lisp. Only a fool would try to do KR without it. The virtue of variables is they allow for open-ended generalization, but that is not part of the large majority of work in the deep learning framework. We've got to have the kind of sensitivity to data that deep learning has, but we've got to also have variables, instances, bindings, and operations over those variables. So when Jeff Hinton says, deep learning has solved everything and hybrids are old-fashioned and all this kind of nonsense, what he's really missing is the power of variables, instances, bindings, and operations over those variables. And that, of course, is prerequisite for knowledge, which is what you guys think about. So you want to have some representation of, if you break a bottle that contains a liquid, some of that liquid is, other things being equal, going to escape the bottle. And pure deep learning systems just don't reliably represent that. There's no concept. So an example here is if you break a glass bottle that holds toy soldiers, the toy soldiers will probably follow you in there. That's complete nonsense, and that nonsense reveals there is no concept or knowledge representation of a bottle or of a soldier and so forth. And that's just not going to work. Another thing that is very unpopular in the larger AI community right now, but I assume doesn't bother you folks too much, is the notion that some of that knowledge actually needs to be innate. So Spelke was writing about children, but you can think about this in terms of KR. If children are endowed innately with the abilities to perceive objects, persons, sets, and places, then they can learn more about those things. But if you don't know anything about the entities in a domain, you haven't done your basic KR work, essentially, it's hard to see how you could single out those entities in their surroundings. So she's shown lots of work from developmental psychology that seems to point to infants having some representations of these early on. I have done some work showing that infants can represent abstract rules even at 7 months old. That kind of work shows that human infants have something innate. I think we need to be looking at what should be the innate basis in our artificial intelligence models. Most deep learning systems try to have essentially nothing except convolution, which is a useful prior, but there's a lot of resistance that I think is just prejudice or sociological. We could talk about that in discussion, that is keeping people from really putting significant amounts of innate structure. That doesn't mean everything needs to be innate. So both Spelke and I are strong proponents of learning, think that learning is very important. We just don't think that you can learn from a blank slate. And my view is that GPT-3 is the ultimate proof of that, right? GPT-3 has as much data as David Hume could ever have imagined, but Hume thought from correlation you could induce concepts, and GPT-3 just never does that. There have to be some prior concepts. Some of the things that I think are innate in humans and that ought to be innate in AI are the following: representations of objects, structured algebraic representations, operations over variables, a type token distinction, capacity to represent sets, locations, paths, trajectories, things like that, a way of representing the affordances of objects, spatiotemporal contiguity and conservation of mass, causality, translation, and variance. Again, KR community finds all of this very comfortable, but it's surprisingly absent from most of the mainstream deep learning work. Of course, there could be even much more innateness than that. So this list was from Steve Pinker's first popular book, The Language Instinct. In the last chapter, he talked about intuitive mechanics, intuitive biology, number, habitat selection, danger, fear, caution, mental maps for large territories, food, contamination. Of course, this is for people, not AI, monitoring of well-being, intuitive psychology, and mental Rolodex, etc. Maybe we need a lot of these, or the analogs for AI systems. Maybe we don't. I think we at least need what I have on the last page. And what I really think we need to do is to focus fundamentally on how we represent knowledge about space, time, and causality. So one of Ernie's favorite examples that we put into Rebooting AI is how you understand a cheese grater. So any game engine can now represent a cheese grater in the sense of having the three-dimensional geometry of it. And so if you wanted to do collision detection and have, you know, if it's a giant cheese grater, you could have a little airplane flying through the holes and do the collision detection, stuff like that. But no system that I know of can take a picture of a grater and even a definition of a grater and relate what those holes are doing to the finished product, or be able to say the way in which you would use the cheese grater is the following given what its function is. So Ernie and I have a paper in artificial intelligence with a couple other people a few years ago that I would love the KR community's feedback on. Lord knows nobody else has even mentioned it, but I think it's an important paper in which we make a proposal about how to reason about containers in terms of things like time and space and history and rigid objects. And I think we need to do more of this kind of work, and I salute you guys for doing it. The third thing, and this will be obvious again to you, but is again missing from most of the world, is if you do good if you do good knowledge representation, if you have the right knowledge, you can actually do pretty fancy reasoning. I think one of the things people debate is whether our reasoners are good enough, and I can make some arguments that they're not. But in the best case, they actually do pretty well. So Leonard has this interesting paper about psych, looking at Romeo and Juliet. I think it's in Forbes or Fortune, one of those last year. And he shows that if you have the right knowledge representations, you can answer subtle questions. Like when she takes the feigned death potion, does Juliet believe Romeo will believe she is alive during the time she is in suspension? Well, this is a really complicated inference to make. There is, you know, GPT cannot possibly do these kinds of things. And Leonard system is able to, but there's a catch. And you guys understand the catch. The catch is that he has not fed in Romeo and Juliet and had the system make this inference. What he has done is he has fed Romeo and Juliet to his KR people who have translated the sentences in Romeo and Juliet into representations in a logical form that the system can represent. And what we really need, clearly, are AI systems that can take text or video, translate them into knowledge propositions that we can then reason over. We're not there yet, but I still take some optimism from these kind of examples. So hype is Andrew Ng saying, if a typical person can do a mental task with less than 1 second of thought, we can probably automate it using AI either now or in the near future. Well, somebody can watch the movie version of Romeo and Juliet and in 1 second understand what's going on. No AI can really do that. The reality is, if a typical person can do a mental task with less than 1 second of thought, and we can gather an enormous amount of directly relevant data, we have a fighting chance. So long as the test data aren't too terribly different from the training data and the domain doesn't change too much over time, which is another way of saying it's no accident that we're good at things like Go, or the DeepMind is good at things like Go, because those are domains where the test data aren't too terribly different from the training data. The domain hasn't changed in 2 millennia. That's where the current techniques are good. But if you want to put your package delivery robot out into the real world, which a whole bunch of people are trying to do right now, it just doesn't work. So what can we do? One of the things I think we need to do to make AI better is to raise the bar. We need to focus on tasks that demand reliability rather than just mere statistical approximation. So if you have a recommendation engine, you can be 70% correct and everybody's happy. I think we need to focus on tasks that make machines work in the open-ended real world and not just closed-end problems like board games and video games and so forth. Second thing I think we need to do is to look at human cognition. Humans learn language, no machine does yet. Humans learn about how the world works, no machines really do yet. What we don't want to necessarily have AI copy human minds, but I think we could learn a lot by studying how humans do the things that machines do better. Doesn't mean we want to build our calculators by copying people, but there are a bunch of things like language and understanding the world where people are better, and we should take some clues. The third thing is we may need to work together on some big problems like machine reasoning that we really haven't made much progress on. And I mean by machine reading, not keyword matching and stuff like that, but actual comprehension. These may be too big for any individual lab and not profitable enough in the near term for corporations to really work that hard on. And so I proposed something like a CERN for AI a number of years ago, focused on machine reading, not just on collecting a bunch of people together from a particular geography. And I think a focus on a problem like that, a challenge problem, could do the field a lot of good. So to summarize, and then I guess maybe I'll show you a cartoon. SARS-CoV-2, COVID-19, in other words, is a wake-up call. It's motivation for us to stop building AI for ad tech and news feeds and so forth, and start building AI that really makes a difference. With better AI, computers might actually be able to read, digest, and synthesize a vast and rapidly growing literature that's too big for individual humans to process, and figure out how to suggest new treatments, how to optimize what we have, and so forth. Computers could also better monitor world preparedness in a variety of domains. In both climate change and the pandemic, like there have been some humans that have given some clues that we should be worried about these things. It would be great if we had computer systems that put probabilities that would actually get people to get off their butts and do something, and monitor in a whole bunch of different domains. Robots might also be able to take on some of the risks that human healthcare workers are facing. To get to that level of AI, though, that can operate in trustworthy ways, even in novel and dynamically changing environments, we need to work towards building systems with deep understanding and not just deep learning. I will pause to recruit and say we need KR people at Robust AI to work on exactly that problem. So visit robust.ai if you'd like to help. The best way to get started on that journey is to focus on developing hybrid knowledge-driven reasoning systems with rich cognitive models, which is what my article, The Next Decade in AI, in February in Archive is about. And here's a cartoon that I think captures a little bit of what I'm saying. Yeah, we can stop the trolley anytime, but doing so would disrupt the trolley service and cause companies to lose profits. You need to make a decision. Are we here about money or bettering the human condition? Thank you very much.